Hi ladies, in this video we're going to go through the theory for the unit circle. Now, there's a lot of theory to get through, so I might actually break this into smaller videos. So as soon as I get to about 20 minutes, I might think about stopping just so I don't bore you or overwhelm you with information. Now, with the unit circle, okay, how it relates to trigonometry, because you're probably thinking, but trigonometry is triangles, unit circle is obviously a circle, but we use trig ratios to work out values on a trig graph, a sine graph, a cos graph, or a tan graph. Now, I just want to draw for you quickly what a sine graph looks like. And it's quite similar to a cos graph, so I'm not going to do a cos graph as well. And tan graph is different, but tan you will look at next year. Okay, so your sine graph is kind of like this, kind of like a series of waves. All right, it goes up and down, up and down, up and down. And it keeps going, just like all graphs. All graphs keep going unless you restrict your domain or your range. Okay, so you restrict your values. And obviously they can continue on in the negative as well. Now with a unit circle, if you think about this first part here is just half a circle. Okay, so there's half a circle. And then if we keep going down again, there's the other half of a circle. So there's your unit circle. And you might be thinking, well, how does that still relate to triangles? Well, in your unit circle, so I'm going to put just a set of axes on here now. A unit circle is called a unit circle because it has a radius of 1. Okay, so there is 1. So unit circle has a radius equal to 1. And on your trig graph, your basic sine graph, oops, that should be number 1. And down here we have -1. Sorry, my drawings are going into each other. But that is basically, you're going around. Okay, so your radius, if we look at your triangle, is 1. And then we go down and across. And down and across. So effectively, we've got a triangle in there. So that triangle will help us find values within our unit circle and values then on our sine graph or a cos graph and eventually your tan graph. Now, with these values, we can remember that our hypotenuse is your longest side. So your hypotenuse is equal to, whoops, what am I doing? I wasn't supposed to write that. I was supposed to write 1. Hypotenuse is equal to 1. But what about your opposite and your adjacent? And where is theta in all of this? So theta always goes from the horizontal. So there it is. Theta just depends on the question what theta is. And opposite and adjacent. So your adjacent side is this distance here, yeah? And this is what we can call x, and here we have y. So this distance here is just whatever it is along the x-axis. So that's x, and then your vertical is your y. So your horizontal, or your opposite side, sorry, I should put theta in, is y, and your adjacent side is x. So if I just scroll down quickly, that's what we've got written here. So I've basically effectively just redrawn that triangle there, probably a bit neater. But sine theta is equal to y, cos theta is equal to x, and tan theta is equal to opposite over adjacent, so sine theta over cos theta. Now I'm going to just put that on hold for now because I want to focus on the initial questions in 4i. So I'm going to just skip. All right. I'm going to, for every question, I'll refer back to the theory when I need to. Okay, so question 1, it says choose an obtuse angle to complete each statement. An obtuse angle is between 90 and 180 degrees. Now, I'm just going to draw my unit circle over here. So your unit circle starts here where I've put 0. So it's a bit different. If you're thinking back to when we did bearings and we always put north up the top, kind of erase that from your memory just while we're doing this. 0 is here and we go in an anti-clockwise direction. So we're going up like this. So this is going to be 90, then this is 180, this is 270, and here we have 360. And we're going in an anti-clockwise direction. Now remember I said before, your angle always goes from the horizontal. So here we have sine 20. So if I'm going to draw my triangle in there, this angle here is 20 degrees. So if we've gone from, let me just change colors. If we've gone from the horizontal here, that's just 20. But we want an obtuse angle. So we've got to kind of think, well, we need an angle between 90 and 180. Okay, that's what obtuse means. And we can just draw the same triangle but on the other side. And remember, your angle has to go from the horizontal. So that's 20 degrees in there. So effectively now we're finding this angle here, which is the same as 180. So if we were to go all the way around, minus 20. So sine 20 is the same as sine 60. Okay, so they're in, 20 degrees. I'm just trying to think of, and different quadrants, but the value is the same. If we were to do the next one, sine 75, the only thing that has changed is theta. So let's just rub that out. And our angle this time is 75. So sine 75 is the same as 180 minus 75, which is 105. All right. Now, the next question, we've got cos 70, and then it says equals negative cos. But in the first one, we had positive sine. Now, what is happening here is in each of your quadrants, sine, cos, and tan are either positive or negative. And it is quite easy to remember which is which, but I might just go back to the theory. Let's scroll up here. Actually, we'll go a little bit further. Here we have our quadrants, quadrant 1, 2, 3, 4. And remember I said we go in an anti-clockwise direction. So we're going in that way. That's why it's 1, 2, 3, 4. Now, in deciding whether you're positive or negative, we've got to decide whether sine or cos is positive or negative in that quadrant. Now, remember back to here from the very start, sine theta is equal to y and cos theta is equal to x. So remember I showed you just briefly here with identifying your hypotenuse, opposite, and adjacent. Now tan theta is equal to sine theta over cos theta because tan is opposite over adjacent. And if your opposite side is y and adjacent is x, then you just get sine theta over cos theta. All right, so coming back to here and deciding whether it's positive or negative. So we do have a set of axes. Okay, so this is x, this is y. Here we have quadrant 1. Now, if you had a point in quadrant 1, Okay, so if we had a point here, your coordinates of that point are just given by x, y. Yeah? So this point here, whatever x is positive. And whatever y is also positive. So that means because x is equal to cos theta in quadrant 1 is positive, sine theta is also positive, and tan theta, because tan is sine over cos, is also positive. Now in your second quadrant, you'll have another point. Remember the coordinates x and y, but in this quadrant, we're in the negative x, okay? Because anything on this side of the y-axis is going to be negative for x, but y is going to be positive. So in this second quadrant, cos is negative, sine is positive, because remember cos is x and sine is y, and because tan is sine over cos, it's also going to be negative. Then in quadrant 3, again, x is negative, but y is also negative. So that means both cos and tan are negative. Sorry, cos and sine are negative. And tan, though, because a negative divided by a negative gives you a positive. And then our last quadrant, quadrant 4, we've got x is positive, but y is negative. So cos theta, because cos is x, is positive. Sine is y, so it's negative. And tan, because it's sine over cos, it's also negative. So how we remember that is just using the letters A, S, T, C. So first quadrant, all are positive. Second quadrant, only sine. Third, only tan. And fourth, only cos. So A, S, T, C. So however you want to remember that, but A, S, T, C will help you remember all sine, tan, cos. All right, so scrolling along back down to question 1, when we're looking at question B, that's why cos is negative, because we're dealing with an angle between 90 and 180, and that's in the second quadrant, and in the second quadrant, cos is negative. All right, so looking at our unit circle, I'm just wondering whether to use the same unit circle. I'll use the same unit circle. Theta, this time is 70. So this is 70, and this is 70. So your angle is just 180 minus 70, which is equal to cos, negative cos 110. Did I do 160? Sorry, the previous one should be 160. I just noticed I wrote 20. It's 160 for question A. All right, so cos 110. And then do the same thing for cos 42, and then tan is also negative because tan is negative in quadrant 2. All right, so you can pause the video now and have a go at doing the rest of them and just check your answers in your textbook. All right, question 2. Choose an obtuse angle to complete each statement. So again, we're doing the same thing, finding an obtuse angle, so an angle between 90 and 180. So in the second quadrant, I'll draw my unit circle again. Let's do a tan this time. So tan 37. And here we have 37. So we're doing question E. So again, we're just doing 180 minus 37. And if you ever wanted to check, you can put tan 37 and tan, what is that going to be, 143 in your calculator, and you get the same answer. So it should be negative 10, 143, and you'll get the same answer. And that comes back to, if I go back to my graph, this isn't a tan graph, it's a sine graph, but you can see you're going to have values, if I was to draw a line going through like this, you're going to get values that are the same. Okay, so that's why you can have more than one answer. And your unit circle, because it's a circle, will keep going. All right, you can keep going around this circle and find more answers. So even though we're looking for an obtuse angle only in the second quadrant, tan is also negative in this quadrant here in our fourth quadrant. Now, it's only asked for the obtuse angle, but if we wanted to find another angle, it's the same as 360 minus 37. So what's that? 223. 323, sorry. 323. Okay, so they're the same. If you put them into the calculator, you would get the same answer. All right, so have a go at doing the rest of them. Okay, you only have to do the obtuse angle. I went on and did another angle just to show, but you only have to do the angle in the second quadrant. All right, question 3. Choose an acute angle to complete each statement. So this time we're kind of working backwards. So let's just quickly draw the unit circle. So sine 150. So that's 150 there. So what is this angle? It's 150. So this angle here is just going to be 180 minus 150. So sine 150 is the same as sine 30. So you're kind of just looking for the two angles to add up to 180, basically. So sine 94 is the same as 180 minus 94. So you can go on and do that. Negative cos 110. Now the reason why they've got that negative there, because we're working in the second quadrant and cos is negative in there. But in the first quadrant, for our acute angle between 0 and 90, cos is positive. So that's why you've got a negative cos and a positive cos. So we're just going to do 180 minus 110. So negative cos 110 is the same as cos 70, and so on. So you can have a go at finishing them. All right. Question 4 we'll do as well, and then I might stop there, just so we can leave it at 20 minutes. So decide in which quadrant theta lies and state whether sine theta, cos theta, and tan theta are positive or negative. So just quickly drawing the unit circle. So we're starting at 0. Remember, we go in an anti-clockwise direction. We go back up to 360. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. In quadrant 1, everything is positive, so sine, cos, and tan are all positive. In quadrant 2, only sine is positive. Quadrant 3, only tan is positive. And quadrant 4, only cos is positive. So when you're doing this one, you can do every second question because you probably will find this one quite easy. Theta is 172. So where is 172? It's between 90 and 180 degrees. So we're in quadrant 2. And sine theta is positive. Cos theta is negative because only sine is positive. And tan theta is also positive. Negative. All right, if we're looking at B, 295, this time we're in quadrant 4. Okay, so in quadrant 4, only cos is positive. So sine theta is negative, cos theta is positive, and tan theta is negative. All right, let's have a look at question C. So 252, we're in quadrant 3. And this time only tan is positive. So sine theta is negative, cos theta is negative, and tan theta is positive. So you can go through and do the rest of them. I'll do every second question if you like. All right, and I might stop there just before we get to 20 minutes. Bye, girls.